This is Dr. R. Perumal from Erode Sengundar Engineering College, Professor of Chemical Engineering. Welcome you all for the session and overview about membrane distillation.
So membrane distillation is a most useful technology in modern separation process, which employs a hydrophobic membrane which operates on a thermal separation process. So like distillation, here also a temperature difference is employed. The driving force is vapor pressure difference. The hydrophobic membrane which selectively allows only vapor to pass through the pores of its membrane. So before going deep into the discussion, let me give you a brief introduction about membrane separation. So what is membrane separation? So in a membrane separation process, a synthetic membrane, polytetrafluoroethylene or polypropylene membrane is employed, which consists of pores. These pores will selectively allow the particular component to pass through the membrane. So depending upon the pore size, the membrane separation can be classified into microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. If the pore size is greater than 0.1 micrometer, it is called microfiltration. If it is between 100 to 2 nanometer, it is called ultrafiltration. If it is between 2 to 1 nanometer, it is nanofiltration. So less than 1 nanometer, it is called reverse osmosis. So the membrane separation process can be classified into pressure driven operations, which employs the pressure difference as the driving force. Then concentration driven operation is operated based on the concentration gradient. The operation in an electric potential gradient, here the voltage difference is applied as a driving force. Then operation in a temperature gradient or temperature difference. So the example for pressure driven operations are microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. The concentration driven operations are classified into dialysis, pervaporation, forward osmosis, artificial lung, and gas separation. Then operation in an electric potential gradient is electrodialysis, membrane electrolysis, electrodeionization, electrofiltration, and fuel cell. Finally, the operations which operates on a temperature gradient is classified into membrane distillation. So coming back to the membrane distillation is a novel separation technology which employs hydrophobic membrane and thermal separation. The driving force used here is partial vapor pressure difference. So the principle for membrane distillation is it operates on the difference in vapor pressure using hydrophobic membranes. It employs non-isothermal fluids, especially water through membranes via vapor phase through the pores of hydrophobic partition. The system consists of a porous hydrophobic membrane separating two aqueous solutions of a non-volatile component maintained at different temperatures. The characteristics of a membrane distillation is it is a thermal separation process. The concentration of particle size is non-sensitive to the thermal temperature differences. It can be operated at a low pressure and a low temperature. So enlarged surface areas, thin water films hydrophobic membranes can be used. It has used 100% guarantee. So we can use multi-stage product. The heat from one stage can be utilized for another stage. So the reuse of heat is possible. And there is since we are using a plastic materials, there is no corrosion or dry membranes, etc. There are no leakages, there is no welding or something else. So no leakage is allowed. So this is a typical example for membrane distillation process. So membrane distillation process consists of a two phase. One is vapor phase, another one is the liquid phase. The feed enters in the liquid phase, the hot fluid enters through the membrane distillation chamber. So the vapor passes through the membranes. The pores in the polytetrafluoroethylene membranes or polypropylene membranes will allow only vapor to pass through the pores. It won't allow the water to pass through it. The passing vapor condenses in the another side and obtained as a permeate. So the advantages of membrane distillation is it can treat almost any water source. It runs on low grade heat. It produces pure distillate. It has high recovery ratios. So the application of membrane distillation is seawater desalination, brackish water desalination, desalination of brine treatment, process water treatment, water purification, removal or concentration of ammonium, resource concentration, concentration of fruit juice, and concentration of chemical and biological solutions. So membrane distillation techniques can be classified into direct contact membrane distillation, air gap membrane distillation, vacuum membrane distillation, sweeping gas membrane distillation, vacuum multi-effect membrane distillation, and permeate gap membrane distillation. So typical membrane distillation process includes the hot fluid is passed through the chamber, the vapor enters into the condensation channel where the coolant is applied, so the vapor condenses and a product is obtained. There are 4 types of membrane. This is the example for 4 types of membrane distillation. The first one is direct contact membrane distillation. Here the hot fluid and cold fluid is directly contact with the membranes. The air gap membrane distillation, there is a gap between hot fluid and cold fluid. The center chamber is called condensation channel, through which the vapor phase deviates from the liquid, separates from the liquid phase. Thanking you.